learners, welcome to the Mindset series. Today we'll be dealing with an interesting topic, the metric topic, grade 12 on momentum. By the end of this lesson, we shall go through interesting aspects about the momentum. We'll be able to define and describe momentum. We should also be able to relate momentum and Newton's second law. And further to that, we should be able to relate momentum and impulse. We are going to see some application of impulse, such as safety features in the car, the use of safety belt, airbags, and crumble zones. And beyond that, we shall stretch our lessons to study conservation of linear momentum and know under what condition does that apply. And after which we will be able to look at some collisions known as elastic and inelastic collision. We'll be able to distinguish collisions as elastic and inelastic, and we'll use calculations to prove whether our collisions are elastic or inelastic. Right, so let's begin. Momentum itself is defined as a product of the mass and the velocity of an object. The symbol for momentum is P. Therefore, P is equal to M times V, where M is a mass in kilograms, our V is a velocity in meters per second, and our P is a momentum in kilogram meters per second. Remember, momentum is a vector quantity, so each time you get your answer of momentum, you should be able to define direction. Say west, east, north, south, to the right, or to the left. Right. Look at one example. Calculate the momentum of a 30-kilogram dog that runs at a velocity of 8 meters per second in the westerly direction. Again, the momentum of a 30-kilogram dog running at a velocity of 8 meters per second in the westerly direction. The first thing we do is to extract our data. The mass is 30 kilograms. Yes, our mass there. Our velocity 8 meters per second. The direction is west. We take west as positive. And then we substitute into our momentum equation. Momentum is equal to mass times velocity. If we substitute our mass as 30 kilograms, substitute our velocity 8 meters per second, our answer is 240 kilograms meters per second west. Remember, we said momentum is a vector quantity. So when we give the magnitude, it must also be accompanied by the direction. Right. Second example, an object with mass 300 kilograms has a momentum of 2.1 times 10 to the 4 kilogram meters per second north. We are asked now to calculate the object's velocity. Let's look at it quickly. We extract the data. Our mass is 300 kilograms. The direction is north. The formula, our momentum is given as 2.1 times 10 to the 4 kilograms meters per second. We substitute into our momentum expression, momentum, mass times velocity. Our momentum was given as 2.1 times 10 to the 4. Our mass is given as 300. We are asked to calculate our velocity. We make velocity subject of the formula, and then our answer is 70 meters per second. Momentum, we want now to look into the relationship between momentum and Newton's second law. Remember, in grade 11, you were told, you were defined Newton's second law was defined as if a net force acts on an object, the object will experience an acceleration in the direction of the net force. We now want to extend our study of Newton's second law to relate it with momentum. Net force equal to mass times acceleration, but remember our acceleration also is a rate of change in velocity. Acceleration, final velocity minus initial over time. If we substitute this into our acceleration, we have final momentum minus initial momentum divided by time. So the final momentum minus initial momentum gives us a change in momentum over time. So we can now define net force in terms of momentum as the rate of change in momentum. The net force exerted on an object is equal to the rate of change in momentum. That is the definition of net force with respect to momentum. We now move into another interesting aspect, quantity known as impulse. Remember, we said the net force, our net force was equal to the rate of change in momentum. If we multiply this, we cross-multiply that, having our net force multiplied by time, it gives us change in momentum. So the net force multiplied by time gives us a change in momentum. This quantity, the product of the net force and time, gives us a quantity known as impulse. Impulse also is a vector quantity because it is the product of a vector. It is a product of vector and scalar. Vector multiplied by scalar quantity give us scalar. Give us vector. I beg your pardon. Now, the unit for impulse is actually Newton's second. Impulse can be measured in Newton's second, or equaling kilogram meters per second. If you break this down, you have this is Newton, which is Newton is equal to mass times acceleration, which is kilogram meters per second squared times second. So if you get that, you also get kilogram meters per second. Impulse is a vector quantity. So impulse in terms of momentum, impulse is equal to the change in momentum. Note, impulse is a vector quantity. I've emphasized that. The SI unit for impulse is Newton second or kilogram meters per second. I'm going to give you a question now to see if you understand where we are going. Let me read out the question for you to follow up. A tennis ball of mass 200 grams is thrown against the wall at 10 meters per second. After colliding with the wall, it moves directly backwards at a velocity of 8 meters per second. So the initial velocity with which it strikes the wall is 10 meters per second, and then the rebound velocity from the wall is 8 meters per second. Two questions for you to answer from here. The first one, 1.1. Calculate the momentum of the ball before it collides with the wall. 2 marks. And then 1.2, the impulse that the ball experiences after colliding with the wall. Welcome back. Let's check if you got the answers right. The first question was to calculate the momentum of the ball before it collides with the wall. Remember, the mass of the object was 200 grams, not in kilograms, and then the initial velocity was 10 meters per second. So if we look into the answer, the first thing we convert, you need to divide 200 grams. We divide our 200 grams by 1,000. That gives us 0.2 kilograms. We take our 0.2 kilograms there. We define our direction. That right is positive, so the rebound velocity, the 8 meters per second, is a negative. That is to the left is negative. So if we multiply that, 0.2, the mass, we have to convert our mass first, remember, into kilograms. After converting our mass, we multiply by the velocity. Our momentum is 2 kilogram meters per second to the right. Then the second question was to calculate the impulse that the ball experiences after colliding with the wall. Remember, impulse is equal to what? Change in momentum. If we look at impulse is equal to change in momentum, we need to know our final momentum minus initial momentum. What was our final momentum? The velocity was 8 meters per second to the left. If we multiply that by that, we get negative 1.6 kilogram meters per second to the left. That is our final momentum. So impulse is change in momentum. We now say our impulse is change in momentum. Final momentum. Please take note of the sign. You do not remove the sign. Final momentum was to the left minus initial momentum that was to the right. And then our final answer is 3.6 kilogram meters per second to the left. Another unit for impulse, remember, it could be what? Newton second. Right. Thank you. See you after the break.